Hi, I'm going to talk a little bit about some properties of limits. So we'll start with this first example, limit x approaches a of x. Hopefully you realize that this will just be a, because, well, for a few reasons. One is the function here. The function here is y equal to x. Y equal to x is a linear function, and we've already established that for limits of linear functions, or indeed any polynomials, those limits are just evaluated with direct simple substitution. B is similar. Here we have the limit of a constant function. Constant functions, as you know, hopefully you realize, those are unchanging functions. Those are in fact constants. So that function, if c is a positive number, would look like this horizontal line. So as x approaches a, this will stay c because it's an unchanging function. Okay, next we're looking at limit x approaches a of x to the n. That's the same as limit x approaches a of x raised to the power n. And so that's the same as a to the n. So raising to a power, that's unaffected by the limit, right? The limit is independent of that, so you can evaluate the limit and then raise to the power to get the result. Now, in the next cases, sums, products, quotients, and so on, for functions, we're going to use these facts, that the limit of f goes to L and the limit of g goes to m. So in this first case, well, why don't you take a moment and think about, maybe pencil in what you think the results would be here, and then we'll take a look at it. Hi, again. I'm hoping you took a moment and paused the video to, fill in these limits. Again, we were using the fact that the limit as x approaches a of f of x is L, limit x approaches a of g of x is m, and so in this first case, when we want the limit of a sum or difference of f and g, that's equal to the sum or difference of the two limits, and so that just gives us L plus or minus m. Similarly, in 2, we have a limit of a product of functions, so that's the product of the limits, and we end up with L times m. The third case, we have a limit of a constant times a function. This character, I apologize, it doesn't actually belong there, so please ignore this character. It's an error. So when we evaluate this limit, this constant function, this constant c is a constant, that's just a multiplier. It's a multiplicative factor. So that can come out front and multiply the limit as x approaches a of f of x, which is c times L. In this case, we have a limit of a quotient, so that's the quotient of the limits. So that will just be L over m, but of course provided m is not 0. This case we have limit of a function raised to a power, so that will be the limit of the function and raise that result to the power, so that will be L raised to the m. And the last case here is the limit of a linear function, and that limit of course can be evaluated with direct substitution, which results in ma plus b.